Q13, the circle with equation x minus 5 all squared plus y minus 3 all squared equals 20 with a center A intersects the circle with equation x minus 10 all squared plus y minus 8 all squared equals 10 with center B at the point P and Q. As you can see on the right hand side here, these are the two circles, and that's the point P and Q. A, find the equation of the line containing the points P and Q in the form of ax plus by plus c equal to 0. So we need to find that equation there. B, find the coordinates of the points P and Q. So we need to find those two coordinates. And C, find the area of the kite. We need to find the area of the kite here. At the point P and Q, the circle are equal, and therefore we can equate this equation with this equation. So now at this point, at point P and Q, I took 20 away from both sides of this equation, and I took 10 away from both sides of that equation. So I get 0 there, 0 there, and then I equate them together. So at that point, the first equation is equal to the second equation. Don't forget to move the 20 to the left and move the 10 to the left, and then you get minus 20 equals 0, and then you get minus 10 equals 0. Because they're equals, you can equate them together. Now we need to expand those brackets and equate them together. For the expansion, I'm going to use, for a minus b all squared, I'm going to use a squared minus 2ab plus b squared. So I'm going to apply that to these, to each one of these. And this is what I got after the expansion using this method for each one of these. I get x squared minus 2 times x times 5, that's minus 10x, plus 5 squared is 25, y squared minus 2 times 3 times y, that's minus 6y, plus 3 squared is 9, minus 20, equals x squared minus 2 times 10 times x, minus 20x, plus 10 squared is 100, plus y squared minus 2 times y times 8, minus 16y squared, minus 16y, plus 8 squared is 64, minus 10. Now I need to simplify. I can see x squared will cancel x squared, and y squared will cancel y squared because there's equal sign between them, and there's a plus y squared and there's a plus y squared, so they cancel each other. Likewise x squared and x squared. Right, so I've got 10x plus 10y plus 14 equals 154. How do I get that? Well, x cancels each other, so that's gone and that's gone. Then I've got 20x minus 20x minus 10x. If I take the 20x to the left here, that goes to, I got minus 10x plus 20x, I got 10x. Then I've got y squared is gone. I also have minus 6y and minus 16 on the right hand side. If I take minus 16y to the, or add 16y to both sides, I'm going to get 10y. And I've got, so that's gone. So now I've got 64 minus 10, that's 54. 54 plus 100 is 154 on the right. And I've got 9 minus 20 minus 11 plus 25 is 14. Then I take away 154 from both sides, so I get 10x plus 10y minus 140 equal to 0. I need to divide both sides by 10. That is the equation of the line here that goes through P and Q. in the form of ax plus by plus c, where a equals to 1, b equals to 1, and c equals to minus 14. This equation is a linear equation because the power of x is 1, so it's linear. B, we now need to find the coordinates of points P and Q. Now that we've found the line, the linear line that goes through P and Q, we now need to find the coordinates of P and Q. P intersect circle B, and P and Q also intersect circle A. It doesn't matter which of the circle we use, so long as we use one of them and equate it to the line of the linear that we just found. From there we can then find the coordinates of P and Q. Now I've chosen the first equation here, and I'm going to work that with second equation, the linear equation here. So I've labeled the first equation as 1 and the linear equation as 2. I've rearranged x by moving the y and minus 4 to the other side. So I go x equals 14 minus y. I'm going to substitute the value of x here into that equation 1. So here are the equations again. So I'm substituting equation 2 into equation 1. Okay, so I've replaced x here with 14 minus y minus 5 all squared plus y minus 3 all squared equals 20. Now I need to simplify and expand the bracket. I have simplified that, so that's 9. 14 minus 5 is 9. 9 minus y all squared plus y minus 3 all squared equals 20. I need to expand this bracket. When I'm doing my expansion, I like to make it simple, so I'm using a minus b all squared equals a squared minus 2ab plus b squared. So for each one of these, this is a, this is b, this is a, this is b. So I'm going to apply this method here for that expansion so I can see what I'm doing. Now a is 9, so 9 squared minus 9 times 2 times y is minus 18y plus y squared plus y squared minus 2 times y times minus 3, so that's minus 6y plus minus 3 squared is plus 9, and that equals 20. So I've got y squared plus y squared equals 2y squared minus 18y minus 6y is minus 24y. 81 plus 9 is 90. 90 take away 20. If we take away 20 from both sides, I get 70, and that equals 0. I've divided both sides by 2, so I get y squared minus 12y plus 35 equal to 0 over 2, which is 0. Now I need to factorize this quadratic equation. A general quadratic equation is ay squared plus by plus c, where a equals 1, b equals minus 12, the coefficient of y is minus 12, the coefficient of y squared is 1, and c is 35. That's the coefficient of y to power 0. Now, AC, I need to find AC because I need to factorize this equation. AC equals 35. When I multiply two numbers together, I will get 35. And when I add them together, I shall get B, and B is minus 12. So I need two numbers I can do that. The usual way I start is by saying alpha is 1 and 35. So I'm using best factors. And then I know if I add 1 and 35, I'm not going to get minus 12. B is minus 12. But the next number factor that I think I can use here is 5 and 7. So with 5 and 7, if I put minus here and minus here, and if I multiply minus 5 times minus 7, I get 35. But if I add them together, I will get minus 12. So all I need to do now is to put y here and y here and y there. Now I can replace minus 5y minus 7y, that will be minus 12y, with there. So I can replace minus 12y with minus 5y minus 7y. Okay, now I've replaced minus 12y with minus 5y and minus 7y. There's a common factor here, y, and there's a common factor here, minus 7. After taking out y here, I get y, open bracket, x, y minus 5, close bracket. After taking minus 7 here, I get minus 7, open bracket, y minus 5. If I expand this, I'll get that back. There's another factor here, y minus 5, and I'm left with y minus 7. So these are the two factors for the quadratic equation here. Y minus 5, y minus 7. I need to set that to 0 and set that to 0 to find the roots. Now I set y minus 5 equal to 0. I get y equals to 5. Y minus 7 equal to 0. I get y equals to 7. Now I need to find the x values for each of the y. I'm using equation 2 here, x equals 14 minus y, to find the x value. When y is 5, 14 minus 5 is 9, so x equals 9 here. And when y is 7, x equals 14 minus 7, so you got y equals 7. Now for p coordinate, we have x equals 7 and y equals 7. For q coordinate, we have x equals 9 and y equals 5. So now for p coordinate, you can see that 7, 7, and for q coordinate, x is 9 and y is 5. C, we need to find the area of A, P, B, Q, kite. This is the kite we're looking for. So actually it's a rectangle here with half of the rectangle missing. This side is not needed, it's just the one inside here. And so that's half of the whole rectangle. So to find the area, then it's going to be, the area will be a half PQ, the length PQ, times the height AB. So we need to find PQ and AB and then multiply them together and divide it by 2. To find the height AB, we need to find the coordinate of A and coordinate of B. And coordinate of A, the biggest circle, is x equals 5, because you have to set that to 0, x equals 5, and y equals 3. So that will be the coordinate of A. So if I draw an arrow there, it's going to be x equals 5 and y equals 3. So that's the coordinate of A. Coordinate of B is going to be x equals 10, y equals 8. You have to set that to 0, set that to 0, and get it. So that's x equals 10 and y equals 8. Right, now to find the distance AB, the height AB, that will be square root of x2 minus x1 squared, all squared, plus y2 minus y1 all squared, where x1 is 5, y1 is 3, x2 is 10, y2 is 8, because this is 0.1, if you like, and that's 0.2. So now put the values in. X2 minus x1, so that'll be 10 minus 5, and that'll be 5 squared. y2 minus y1, that'll be 8 minus 3, 8 minus 3 squared, that'll be 5 squared, which is 5 squared is 25 plus 25, that's square root 50. AB is square root 50. Now we need to find the length PQ. P has a coordinate 7, 7, and Q has a coordinate 9, 5. And that coordinate is, this is x1, y1, x2, y2. Therefore, to find the length PQ, that will be square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now we need to substitute those values into this equation here to find PQ. So substituting the values in, it is 9 minus 7 all squared plus 5 minus 7 all squared. So PQ equals 2 squared plus minus 2 squared, or root. PQ equals root of 8. Root of 8 is root 4 times 2. Root of 4 is 2, and you're left with root 2. So therefore, PQ is 2 root 2. Let's simplify root of 50, which equals root 25 times root 2, which equals 5. Root 25 is 5, so that's 5 root 2. So the area will be equal to a half 5 root 2 times 2 root 2, which equals, well, the 2 here, we cancel the 2 there, and root 2 times root 2 is 2 from the law of indices, where you have root a times root a equals a, and therefore you're going to have 5 times 2, which equals to 10. So that will be 10 units squared. If there was no unit provided in your answer, you need to give unit squared. In this case, there was no unit provided, so you have to write unit squared.